Hello and welcome to part 3 of my video series about descriptive statistics, specifically dealing with what we do with psychological statistics. Now, I create these for my own classes in psychological statistics. I can't guarantee that I'll cover everything that you would need for any class that you're taking having to do with statistics, but previously I talked about computing various things like computing the mean for a set of scores. The mean for this particular set of scores was 2.2. Oh, can't quite see it there. 2.2. And we also computed deviation scores, and then we summed those deviation scores to get what we call our sum of squared deviations, which was 2.8 for this set of data. So what can we do with that? What can we do with the sum of squared deviations? Well, we can use it to compute something called variance. Now, variance, it's abbreviated differently depending on whether you're talking about a population or a sample. Now, if you're dealing with a population, let's say we've got a tiny little population with just five individuals in there. If it's a population, it is this little small sigma symbol. I don't make it perfectly. If it's a sample, you would use S squared. Both of them have the squared symbol, all right? So S squared is for a sample. Small sigma, lowercase sigma squared is for a population. Now, how do we compute it? The formula is a little different depending on whether you're dealing with a population or a sample. And you might hear my ice maker going in the background. I apologize if you do. So the formula for the variance for a population is sum of squared deviations. Hopefully you can see that there. Sum of squared deviations, this number that we computed down here, divided by n. And in this case, n is the population size, right? So here, if we're pretending this is a population here, we go 1, 2, 3, 4, 5. That would be our n. Now, if it's a sample drawn from a population, if we're computing a statistic instead of a parameter is one way to say it, our S squared, our sample variance, is sum of squared deviations, remember the same value down here, divided by n minus 1. So you do have to do it a little bit differently depending on whether it's a population or sample. So I always remind my students, pay attention to any word problems, any questions on quizzes or tests. Look for the words population or sample to give you a hint about which specific formula to use. They're very similar, but that minus 1 can make a big difference. So in this case, we'd have to do 5 minus 1, so it would be 4 in this case. So using our formulas and using this value for sum of squared deviations that we got previously, all right, for 2.8. So if we divide 2.8 by 5, if it was a population, we get 0.56. If we say this is a sample, we divide 2.8 by 4, which gives us 0.7. So you do get a different value depending on whether it's a population or a sample. So that's one indicator of variability. Variance is one indicator of variability. And for future things that I'm going to discuss, there are formulas where you have to know the variance of something. And so this is how you get there. Lots of steps to get to variance, and then additional steps once you have your variance sometimes. All right, but that's how you would get it, but you have to pay attention to whether you're dealing with a population or a sample. Now, there is another indicator of variability that is commonly used, and that's called standard deviation. Now, how do we get standard deviation? Well, you might have noticed that variance, no matter how you calculate it, it has a squared symbol. Well, if you were to take the square root of that variance, that's how you get standard deviation. It's as simple as square root of variance if you happen to have variance. I'm getting closer to the board so that you can see what I did here for standard deviation. Hopefully you can see that. So if we take the square root of 0.56, if we're dealing with a population, we would get a standard deviation of 0.75. Now, how do we abbreviate standard deviation? It's the same small sigma symbol. Small sigma symbol, say that fast, without the squared. To get S without the squared, just S, standard deviation for the sample, you take the square root of 0.7, you get 0.84, that's your standard deviation if this is a sample. Right, hopefully that made some sense. And in the future, I'm not sure exactly what I'm going to cover in the next video, but here you've got, in these 3 parts, you've got some widely used descriptive statistics. And I might add some more in the future if people request them, or I think of things that it would be good for people to know.